Hello, everyone. Like Ash mentioned, since last year's presentation in Dubai, there was a lot of feedback, there were a lot of inputs. Um, Probably because last time it was not right after lunch. So I hope this time around, maybe less questions, I'll be able to address, not because it is right after lunch, but because I'll be able to address some of the concerns. So, uh, last time the technical debt topic was actually technical in nature. This time around, it's getting bit more around business. We are going to talk about how do we plan investments to be able to manage the technical debt. Yeah. About me, so within Axion, I look after pre-sales and solutions for UK, Europe, Middle East, Africa, Geo. I also work closely with Ash in the back end for our global pre-sales governance. I'm a techno-functional person. I consider myself, um, I have the ability to connect business with technology and solutions and connect the dots where it matters. That's my specialty. So before I begin, um, I also want to mention, yeah, day before yesterday, Frederick talked about moving like Mongolian. So I guess we are actually following that. Consider this to be a sequel of last year, and who knows, maybe next year we'll have further this thing. So we are moving our, while the topic is same, but we are moving our subject with new findings, new explorations. So we are moving like Mongolians, trying to learn ourselves as well as share with everyone. I, I just want to get a sense how many of you were there last year and uh, had attended the technical debt session. So I see about 30 to 40% hands raised. Good, good for me, but I guess for the rest, I will do a quick recap of what we talked about last year. So we came up with our own understanding of technical debt, having worked with 120 plus customers, having interacted with them as part of engineering, delivering requirements day in, day out. And we said it is additional time and cost requires to close the gap between the requirements, expectations versus the actual fulfillment. Um, in simple, and we've tried to put it in very simple terms that it is a debt between expectations and actual deliverable, right? And we also talked about the fact that when this gap widens, as it keeps increasing, and the output that you are giving starts falling negative in terms of time and effort, right? Then you are looking at technical bankruptcy. So these were the two concepts we covered last year. I'm not going to get into further details of that. We talked about how at different stages of product development life cycle, technical debt behaves, and then what could be the causes and what actions you can typically apply. And these are primarily engineering actions. We talked about the fact that when you are a new startup kind of or early stages of your product development, you are looking to just come up with an MVP. You don't necessarily create a technical debt that will impact a lot of things. You're still developing. Most of the debt will be in your code in the form of code defects or issues, and the solutions to those things will be simple in terms of refactor, review, and rewrite. As long as you're reviewing, as long as you're keeping your eyes on it, you will be able to address it. As you grow as a company, you have your product out in the market and you are growing, let's say rapidly, let's take a positive scenario. Um, uh, the expectations from the market increase, a lot of things start coming up, more customers, more requirements, more features, and that's where process starts mattering more and more, your engineering process. And if you have if you have gaps there, if you have not yet matured your processes, then this is the time you want to address your processes. So even if you have your processes, you want to automate, you want to optimize, so that you can turn around faster, you can keep pace with the growth that you are expecting. You become a mature organization, you are out there in the market, you have a good name, you have a stable product. But from the point where you started, your technology has also matured, a lot of things have changed. Some of the frameworks you might have used have become outdated. Some of the requirements which you came up with at that time are no longer relevant. So you now look at this from that perspective. You look at replacing or remigrating or recreating certain things. Last scenario is when if you don't, if you are not able to keep pace with that growth, right? Then, like we saw, you 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 come to the point where the architectural debt, which is the most critical kind of debt among all, is what comes up, and this is when you take a call that okay, you need to either re-engineer or modernize your product. So this is what we looked at. I briefly covered this. Uh, and the last bit that I want to cover from last year is we came up with a methodology. We shared what we think is the way to address the technical debt. It is a simple process. You discover what's there on the ground, you analyze what you discover, and then you prioritize and plan, right? And we also talked about different types of metrics. Keep in mind that all these metrics are primarily engineering metrics. Yeah. So, and we last year as well as this year also, we have sessions by different, like Mandar had one yesterday, Aarti will cover for UX, Saurav will cover for architecture, and likewise. So, all of these factors in terms of the maturity, the ability to measure, are relevant from that perspective. Now, you might wonder that, okay, fine, so there is a way we can measure, there is a way we can address technical debt, then what is the issue? Well, it's not so straightforward because when we look at the state of the industry, right, the industry is still, even after so many decades, I think first time that word technical debt was coined was more than 3 decades back. Ever since, technical debt is still being discussed, it's still growing in different forms and shapes. Initially, it was about code quality. Nowadays, it encompasses much larger scope. It talks about architecture, it talks about data, processes, everything within the engineering domain. And the impact is no longer restricted to, say, engineering or coding issues or architectural issues. It has started impacting the business. Some of the figures tell you the current state, very much state at this point in time, that and it's something that we are also experiencing. Like I said, every day talking to our customers, we do get the feedback that it's not easy for them to manage the technical debt. So let's try to figure out why it is so difficult to manage, right? What is happening while industry has come up with so many methodologies, there are research papers out there, there are analysts talking about this is how you should go about it, this is how you can address your technical debt. and it still doesn't go away, right? And our friend Dilbert went into the same situation. But let's look at it from outside in perspective. And when I say that, look at this response. Yeah, it talks about, okay, budget, go and make a proposal, I'll look at it, I'll approve it, and likewise, right? So that tells us a story that there is something beyond engineering that needs to be looked at, right? So let's look at it. What's happening? As an engineering organization, when you typically know most of the times that certain compromises are being made in your product implementation. The reasons could be business decision, the reasons could be your own engineering decisions, or it could be ignorance in some cases, right? Essentially, all those decisions translate into some kind of errors or compromises, right? And like I said, most of the times engineering is aware that there are certain compromises taking place. And if you do the root cause analysis of those, ownership typically will come down to engineering. The responsible for that occurrence could be decision from somewhere else, doesn't matter, but it's engineering who, resides at the center of the gravity, right? Now, for engineering, while methodologies are there, mechanisms are there, addressing technical debt still becomes a problem because they need to be able to justify the investment that is required to address the technical debt. And the very fact that justification is not being done to engineering itself, it is to be done to the organization outside engineering. If it was pure engineering language, right, it would have been straightforward. In some cases, yes, the debt could be purely engineering debt and it could still be handled internally within engineering. But those ones are not the ones typically which will impact your business as well. So engineering needs a language and a mechanism to be able to address and justify the investment that is required. And this is what the core challenge is. This is what we learned based on the feedback that we received post last year's session. Some of the customers came back and said, oh, in our organization, technical debt is primarily code quality perspective. And that is something we are addressing, right? But then why there is so much business impact? Why do you even discuss about re-engineering something, modernizing something, or refactoring something, right? If it was so straightforward. That means it is not just about code quality. There is something much bigger. If it was so easy to communicate, right? And just say, oh, okay, I just need to fix the problem here in the process or here in the architecture. And I need X number of days and Y number of people, right? Every company would have been doing it. But that's not the case. It's not so straightforward. The question that would also come up is, okay, if you knew this, why didn't you fix it? Why did it even happen in the first place, right? So the point we are making, the learning that we have is that while mechanisms are there, methodology is there, and engineering knows what to do, the challenge for engineering in managing the technical debt is to be able to justify the investments by tying it into the business outcomes. That's the key. I think yesterday we saw a very good example from Rotary by Paul and Mary. And incidentally, some of the examples I'm going to take are almost ditto with the case of Rotary. So we'll look into it. And I think that only validates the understanding that we have developed and why we need to relook at our definition as well as how do we approach addressing or managing the technical debt. So let's relook at it. Now we know the problem statement that we should be able to justify the investments required for the technical debt. And we need to be able to tie it into the business outcomes. And hence, we relooked at our definition. We said, okay, it's the output which matters. It is the time and it's that gap, delta, between the expectations and the actual output, right? What is that output? It was implicit understanding last year that the output we are talking about is engineering matrix. It is your code quality, it is your velocity, it is your data quality, and likewise, all different engineering metrics that we talk about. However, these metrics may not be directly relevant to business. Business is looking at something different. Business is looking at, okay, is my customer satisfied? Are my product features getting delivered on time? Right? And hence, this output that we defined does not necessarily give you the picture that from the business point of view. The gap that we are talking about, if it does not talk about the business impact, then it does not help you in justifying the investment. And like I said, one of the feedback that was that, oh, it's a code quality issue. Well, if you look at code quality issue as technical debt, then that means it's such a narrow perspective that you will never be able to talk about business impact beyond that. Because an issue like a duplicate code or an issue of certain file not following coding standards is not likely to have business impact in most cases by itself, unless it has certain functional or business relevance to what it is doing, right? So we need to relook at the output. We said that output in this particular case, in the context of being able to justify the investment, needs to be measured in the form of business metrics and not engineering metrics. Let's try to understand when we do this, right, who gets impacted. And like I said, it's very, very identical example to what Rotary faced in their organization. So it is, we said that, okay, we know there is a technical debt in the form of inconsistent data quality issue, essentially. Let's look at it one by one, very quickly, yeah? So what it means is, the processes which depend on this data, right, are going to get compromised, right? Because these processes will produce unreliable results because the data which is driving it is unreliable, the quality is not good. On the other hand, your developers who rely on this data for their coding, for their testing, to produce the output, are going to be impacted because they will be introducing bugs and the inefficiencies. So process, code quality, manual interventions, because if your processes are not good, there'll be exceptions, there'll be errors, process will fall, and you will have to do manual intervention. That means more effort. Your workforce now gets impacted because in large organization context, the more activities, the more tasks which are impacted, and the more manual work, manual intervention that is required will make your workforce unhappy. They are not really keen to do this kind of work, especially if they are data specialists, right? And we make them, do manual swill chairing activities kind of stuff. then it's an increased workload for them, and that directly impacts the employee work satisfaction, right? Second part, so process unreliable results means the reports which were getting produced were unreliable. The metrics getting measured were not reliable. Hence, who is getting impacted? The decision makers. This could be sales, this could be finance, this could be product. Third bit is the more architectural stream, where inconsistent data definitions lead to inconsistent designs. Inconsistent designs lead to higher effort on maintenance, higher effort, or it impacts the overall system architecture. The data retrieval patterns impact your performance, and hence the resources required to ensure the stability of your product infrastructure is impacted. So what's happening? Let's try to see who gets impacted, right? Let's look at this. This is a cascading impact, effectively, if you see. So first in place, of course, engineering knows that it is impacted. Who got impacted? Within engineering, all the metrics related to data, related to process, the code quality, the architecture, all of these as part of cascading impact are affected. But more importantly, this impact has cascaded into business. You see, your workforce, which is your HR and people organization, your decision makers, product, sales, finance, your infrastructure. So these elements of your ecosystem, organizational ecosystem, which sits outside the engineering and what we call business, is also impacted. And that's what led us to define this technical debt impact ecosystem, where engineering is at the core, the engineering matrix resides at the center of the gravity, but nothing is in isolation. You have different functions: product, finance, sales, operations, support, HR and people, IT and infrastructure. Everyone has a bidirectional impact flow. And no element exists in isolation. The impact doesn't exist in isolation, typically. Yeah, anywhere there is a business impact, there will be the impact will be across the multiple elements as part of the end-to-end ecosystem. So now, having understood who gets impacted, right, what is the way we can analyze? What do we do to analyze this impact? We came up with these factors that any impact, any technical debt, if you want to address, in this case, we took example of data quality issue. So if you want to address data quality issue, right, it's not straightforward, right? It's not like going to your database or data store and suddenly changing some of the fields or changing tables. It doesn't work that way, right? You need inputs. You need the inputs about what is the right data then, what are the right data definitions in that case, right? What will be the right validations of that data, right? All these inputs come from business. Because you want to make this change happen, you are also dependent on your HR and people organization to get the right specialists, right? You need right people, you need right skills. So the inputs which you require, to make this change happen, you have dependencies. Those are the input business metrics. You have engineering, and there can be internal interdependencies within engineering. And then you have output dependencies. These three things, if we measure, then we are able to analyze the impact. Here, we have gone reverse to analyze the impact, because we said that even if we know that data quality is an issue, to address the technical debt and to be able to justify the investment, we will look at the business impact first. The business impact starts from, in this case, low customer satisfaction. So sales comes and complains that my customers are not happy. They're not getting the right reports. They are raising too many tickets. So why low customer satisfaction? Because there are too many tickets. I think ditto case similar to Rotary, right? Large number of tickets. Why is that? That's because the reports which are going to customer are inaccurate. Why is that? That's because the data which is driving this report is inaccurate. And so we know it's a data quality issue, right? In terms of impact analysis. Let's go beyond that. Why data quality issue arose? Of course, it could be something you started off with. I mean, you started off with the bad data, but it could also be that while the data is there is no validation of data being done. And the data is originating from multiple sources, right? It could be coming from outside organization. It could be certain internal data. It could be a variety of other integrations through which the data is coming. And because you want to find out what it will need to address this problem, you will go and say, okay, you can ask a question to engineering that you knew this problem. Why didn't you fix it? Why didn't you implement the validation on your top of your data? Engineering comes and says, oh yes, I knew, but the time and effort I was given at a given point in time was not sufficient. There are just too many forms within my product, too many permutations and combinations, and too much testing to be done to meet your release cycles and your requirements, right? So the root cause analysis goes beyond data quality. It gets into the space where it needs to be addressed through engineering as well as non-engineering problem. And this kind of analysis will now help us to calculate the investment required. We are calculating the investments and we are putting the case in the form of business impact, right? We are not putting the business case in the form of, okay, I need 2 people for 3 months and data quality will be fixed. Data quality issue is not a business issue per se. It is an engineering issue. We are talking about the benefits that we want to derive out of this. Once you fix your customer satisfaction score, right, the business benefits is what you should be able to quantify in the form of the cost savings, the revenue gains, the improved customer experience overall, right? To calculate the investment, you will factor in the costs. We already talked about what are those inputs, right? What is it that this change is dependent on, right? So the cost will come in the form of the implementation of data validation. You need people, you need a certain change in infrastructure. So whatever those costs are, you factor in, you project the benefits once this is implemented. In this case, one of the key challenge was too many tickets. So you bring down the number of tickets. You have reports which were inaccurate. So you improve your reports and that in turn improves your reducing your customer churn, improving your sales, reducing your marketing cost and likewise, right? And the numbers are there for example, but overall you are able to build a case, a return on investment case by doing this kind of impact analysis. Now, you've done the analysis, you've justified your business case, you need to be able to translate this into manageable plan, right? Of course, this is a very high level view. We already looked at the business inputs, the engineering impact, the business output. Now, having done that, every technical debt item will need to be strategized and prioritized. It can essentially translate into your actions and priorities And this could be strategic in nature, this could be tactical in nature, or this could be something you want to do incremental basis because you're not very sure yet that the impact you are anticipating will be as much as what you have provided. And this third case will typically be applicable when you when you don't see impact of technical debt as yet. I'll explain that what I mean. Before that, so what has happened? I'll just summarize quickly the entire cycle. Decisions were made by engineering or business or some ignorance, right? These were the causes. That generates your debt. That debt may not be visible as yet, but the debt has been created in the form of errors or compromises. This debt leads to consequences. It will impact your engineering matrix. It will impact gradually your business matrix, right? So, and then eventually it becomes visible in the form of symptoms. It is when your customers start feeling the brunt of it, by your sales, your finance, your business organization, or even engineering organization, when there is a visible signal that tells you that something is very wrong, right? So that is when this consequence starts displaying the symptoms. Now, the scenario that we took earlier for the impact analysis, I call it post-impact analysis. Why so? Because we are doing the analysis after the impact has already been felt. The customer satisfaction is already impacted. In case of Rotary, the impact was such a huge, 2.5 million, if I remember correctly, that they decided to go for modernization journey, which means there was a technical bankruptcy. It reached a point where just simple ongoing fixes, refactoring wouldn't help. There was a modernization that is required. So at that point, and because the impact has been already felt, and now we are reacting, we call it post-impact analysis. Once you do the impact analysis, the way we looked at, and you create the plan, you have a exit route. But there is another point. What if we want to act proactively? Even before the impact is felt, we want to go and identify what could be the potential impact of what is happening now. While the methodology or the impact analysis mechanism will remain same, what you will do is you will start looking at your metrics proactively, ongoing basis. You will identify your ongoing metrics where there is some gap. So for example, engineering knew there is a problem with data quality, right? It's just that it was not visible to business and they didn't realize the impact it will create, right? And hence the action was not taken. There was no justification to take action. But if engineering creates a potential impact analysis and a business case proactively with the same mechanism, with the same methodology, then they can actually justify the investment proactively and can fix it before it reaches the point where then you have to call it as a technical bankruptcy and the impact is already felt and now you take a decision to modernize, which is much larger cost and much larger business impact. So that's the way we can look at justifying the investment to manage the technical debt. And last lessons from Dilbert, this is not my lesson. The lesson from Dilbert is that it doesn't work if everyone does it. So you can remember action when it doesn't work for you.
So I think the first question really is why do we need to be reactive in case of technical debt, and why do we wait for the impact? Why don't we, how can we and why should, how can we do proactive? I think you talked about
Yeah.
that you can do proactive, but there are a couple of questions on also saying, so how do you know the value of potential impact when the impact has not yet happened?
So to answer that, and the reason I did not take a separate example of proactive impact, although I covered it, that you can actually do it, because the mechanism and the analysis will remain pretty much identical as the post-impact analysis. It is just the action that you take on a proactive manner to measure that impact. So like I said, the post-impact analysis we did was originating from the fact that customer satisfaction is low, right? Proactive impact analysis you will do as an engineering is because you know that data quality is not good. Although business hasn't felt any impact, right? But you know that your metrics, which measures data quality, is not good. So you'll do the exact same cycle, where it starts from data quality, then you start drawing your impact graphs, right? Based on the ecosystem. Okay, it's data quality, then my reports are not good, then my customer is getting away, my workforce is getting impacted. So that value chain, if you put across and you do the analysis, and then you put a number to it based on what your organization, what fits your organization's value chain, then you should be able to do proactive impact analysis for that with the same mechanism. It doesn't require a separate methodology.
So even if you've done the analysis, how do you get the rest of the business to believe or attach importance to the analysis? And how do you rationalize the trade-off of technical debt versus new features?
So to make business believe, I think that was the whole session about that. Justifying the investment is a very challenging task because it is a business you are trying to justify to, and they don't. If you go and tell them that my velocity is down, you talk in terms of engineering metrics. It's unlikely in most cases that it is going to work, and hence we talked about the impact in terms of business metrics, your customer satisfaction, your product feature output. You talk about any other business metric, and business will have to listen to that as soon as it starts impacting the sales organization, the finance organization. You're talking about numbers that finance understands. You're talking about numbers that business understands, sales understands. Then I mean, that's what matters to be able to convince to business.
So in your example of data quality, do you propose that engineering take the responsibility of reducing the number of support tickets?
Well, like I said earlier, there are two things. One is ownership and the other is responsibility. You, you can, uh, you can blame per se in anyone, okay? Maybe the data inputs, the data requirements that came from product was not right. But it is a common sense that the fixing will have to be done by engineering ultimately. So, and of course, everyone else needs to support, right? But if you want to if you want to fix the system, if you want to fix the data quality, it will come down to data engineering. Engineering will not be able to escape that. And hence it is, I mean, the entire thought process this year has been turned around with this perspective that last year we talked purely in engineering terms, and we realized that convincing the business with purely in engineering terms is not something that's going to fly.
So I think you're saying your answer is to that question is that you represent your initiative in terms of metrics that business understands and
Yes.
hope
And hope, yes.
that business actually
Yeah, because I'm,
assigns some importance to it. At least you're talking the same language as them in
as
some
them.
ways. Um, So there are other questions which are a little more questioning the prioritization. I think even the previous question raised this question of how do you prioritize technical debt versus new features? Is there any formula that you can recommend on how do you propose to prioritize between adding new features versus addressing technical debt?
Yeah, we have actually attempted to create a mechanism to prioritize. I have to say that there is no there is no formula because this can vary from organization to organization and business priorities for each organization. But there can be guidelines or there can be a framework based on which you can prioritize. We didn't cover it this year, possibly next year. We do have a mechanism that can help you prioritize all your technical debt items. And just to give you very briefly to share with you, the priorities are primarily driven by the combination of technical impact and business impact. You categorize this impact in certain range, say low, medium, moderate, high, critical. Likewise, you create a matrix out of it, and every technical debt item can be then placed based on actual calculated technical, not calculated, but actual derived understanding of technical impact and business impact, and you can accordingly prioritize. This is just a framework. But like I said, business can always come and say, not this, but this.
Question is more from a perspective of how do you assign weightage to both of these seemingly conflicting objectives. So certainly, I think converting it into some kind of metrics will help in adding the weightage, but the calculations are still, how shall we say,
Yeah.
hypothetical.
Yeah,
And so-
you can't have a definite system. It's not exact science.